Hello, welcome back. Okay, so this will be going over Lunabotics scoring and how you can leverage that to make engineering decisions. So there are four ways to score. So these are the only four ways that you should really be four things that you should really be concerning yourself with outside of like reliability when it comes to your rover, at least. So one, burn volume is king. It's 50% of your score. Okay, just at the end of the day, we're stacking berm. So please, that is the most important thing. Um, this is nice to look at because it kind of gives you an idea of what is most important, what's least important, because that's not necessarily entirely obvious just by looking at the raw um, equations that they use for scoring. But yeah, so construction score, that's like going to be your main thing here. Autonomy, I'll get to that later, but that's also very important because the way that our rover is moving, um, we get to a point where it's difficult for us to score more berm uh, outside of just. So we are going to need autonomy because we have diminishing returns um, as our games progress because we've stacked the berm so high and we've torn up the excavation field so much. Camera usage is another one. So this refers to the cameras that you don't use. So you get, I forget what the specifics are, but it's something like you start off with 120 points and then you're deducted 60 points based off of how many arena cameras you use. i.e., you don't want to use arena cameras. Instead, you want to try and get some cameras on your rover so that you can use those instead. From talking with people at competition, the main concern is trying to get those cameras to have as little latency as possible. That'll be the biggest hurdle. But of course, I mean, the arena cameras already have latency, so you might as well at least get the points for it. Dust penalty, they go more in depth in the rules, but essentially it's broken up into two categories: how much dust you actually create, and then your design for preventing dust. So put like guards over your chain, your gearboxes, right? Make sure um, dust isn't like getting everywhere, right? Okay, so from construction, we can see, looking at this, that as a general rule of thumb, our berm volume is twice as important as our weight and our energy consumption. This is a general rule of thumb, right? So for example, the way we used this last year was originally our gearbox had only 2 stages, and we're thinking about adding a third stage. So from using our motor calculator, we were seeing that if we were to add an additional stage, we would be, I think it was like 20% more energy efficient. However, we'd be adding more weight to our rover, right? So how do we know? So how do we know that this is a worthwhile venture? Well, we can see that weight and energy, right, are roughly equal. Weight is 50% more important than energy. Well, we know that we're going to add like 1 pound to our 1 or 2 pounds to our rover by adding an additional stage, right? Which is like less than 1% of our total weight. And then versus the energy savings that we're getting from the additional gearbox, we can use this rule of thumb if it's not already obvious. Hey, we need to add that next stage. So this kind of just gives you the confidence to say, okay, we know for sure that this is a worthwhile venture. To get more specific, we can use the exact competition equations. These are really helpful for tuning your motors. For example, you can say, okay, we're going to have our excavator dig for, 1 minute, right? And then we're going to measure how much berm volume we've collected and how much energy was consumed, okay? So as you increase the motor speed of that excavator, right, you're using more energy, but you're also collecting berm more quickly, right? So how do we figure out, right, where that equilibrium is, where that balance is, where that apex is, right? Is we can plug in all this data and just see what our highest score is. And what you'll find is something kind of interesting happens where notice how our mass variable isn't really filled in here. You'll notice that given certain, if your rover weighs like, say, as like an example, like less than 120 pounds or something like that, there are certain cases where a motor speed will not be will not be as beneficial to you as it would a rover that's like heavier, which is a bit counterintuitive because like what the hell does mass have to do with me just running the excavator and just collecting berm volume and getting time, right? Seemingly mass has like nothing to do with it, but turns out it has like quite a bit to where it's like if you were to solve that hypothetical I was talking about earlier, you'd find that there's like a break even point where if like say a rover were to weigh like 80 pounds, like both the cases that you're comparing are equal. But if it were to be like 100 pounds, then like maybe case one is better than case two, right? It's like really interesting like that. And it kind of explains away some of the interesting things you'll see in scoring when you start looking at some of the charts of how other teams have done. But yeah, this is pretty good for motor tuning, so you can get exact values and know what's best, right? What motor speed is best. Secondly is autonomous. Autonomous is going to be super important for us this year, probably the second most important thing next to just increasing the reliability of our rover. We want to be able to do the traversal autonomous. So we were able to figure out the excavation deposition autonomous last year. We just ran time-based commands and it worked out. We ended up getting first in autonomous just because of that, which is kind of crazy, but that's how it is. But something we've kind of noticed on the rounds that we have completed on the beach is that our berm, we have kind of diminishing returns as we continue to play because the field gets more torn up. Our berm heights get pretty high to where it becomes difficult for us to keep stacking berm. So we do need an additional autonomous to compensate for those diminishing returns just because our rover is pretty efficient. And then camera usage, dust prevention, kind of what I was talking about earlier. Okay, so berm volume and its relevant variables. So you need to know the variables that come into getting berm volume. This stuff is going to seem obvious, but its application is less obvious. Excavation time is king. So if you were to imagine an optimal game that's being played here, your rover is excavating and storing the entire game, and then at the very end, it goes back and dumps. That would be the optimal game, right? So we need to design around trying to, obviously we're not going to get it, but we need to get as close as we can to that, right? And that comes with having high effective storage, right? So regolith that you can actually store. which is different than the volume of the container that you have. They are different. That's why we went for a conveyor design, because we were able to distribute our regolith across our storage area a lot better, which increased our effective volume. So something to think about here is that, let's say you were to so storage is very much so overlooked. Storage is extremely important. So if you think about it like this, let's say you have 2 robots, right? They're all the same, except one robot has double the storage of the other. Now we know that that one is going to be better, but how much better is it going to be? Well, the more storage you have, right, the less time you're spending transporting, the less time you're spending depositing, right? So the less time you're actually increasing your potential points, right? Because we want to spend most of our time excavating, right? That's what we kind of learned from our hypothetical earlier, our optimal case. We want to spend all of our time excavating. So let's say those 2 robots, they both spend, or the first robot with half as much storage spends like 8 minutes in total transporting and depositing, right? So that means, because we have double the storage, right, we are going to spend 4 minutes transporting and depositing, right? So we have an extra 4 minutes of collecting berm and dumping berm that robot does not have, which doesn't seem like a lot, but you can get a lot done in 4 minutes, especially with our rover. So you can kind of see how that actually plays into storage being pretty important. And that's going to play into our design changes of, we want to increase our effective storage capacity. And yeah, so for the most part, that was the Lunabotics scoring section. Pretty straightforward for the most part. It's just learning how to find these straightforward things and finding use cases for them so that you can make better engineering decisions. That's kind of the hard part. And yeah, thank you.